Welcome to the Your Cloud Group 3-Minute AI Tip Series. There's tremendous confusion right now about the pros and cons of AI, what it is, what it can and can't do. Then add the question every owner is asking, how does a business use any of this without a billion-dollar data center and without a lawsuit over an answer its own software gave a customer? 3 minutes at a time, this series will dispel the myths and point businesses at AI procedures they can trust and act on. What you see here on the first slide of this presentation is matrix multiplication. The rows that you have in your data times weights, which produces a model, which is reusable and deterministic. Most teams asking for AI don't need an LLM and frankly don't want an LLM. They need a target column. If you have a CSV file, comma separated value file, with the answer already in it, a model you train in an afternoon will beat GPT and Claude and any other LLM at that job, and it'll do it faster, cheaper, and it won't make things up. AI isn't magic. It's a probability of possible outcomes. People are confusing AI with intelligence. What's actually happening underneath is a statistical prediction, a curve fitted through data you already have. Prediction on things that have already happened. Here's what goes wrong using an LLM. A team wants to predict which customers churn, so they wire up an API, write a 900-word prompt, paste in customer records, and ask the model to guess. It costs money per row, it's slow, and the answer can change between runs. And nobody can explain why it said what it said. Because models are opaque. You cannot tell what a model will predict before it spits the prediction out. Look at these two models here, these two graphics. They both represent models. They're the same object. The one on the left isn't a worse maze. It's the same maze with a lid on it, and you can't determine what's going on inside it. Opacity isn't a property of the model, it's what you get when the domain is unbounded. This is a critical thing to understand. You fix the domain that the model is trained on. You train on your own labeled rows, and the route from start to target turns into something you can trace, you can audit, and you can guarantee. This is something you cannot do with an LLM model. So you name the prediction, not the technology. Before you pick a model, write one sentence. Given X, predict Y. Google's ML problem framing guide. Google's ML problem framing guide is built entirely around this. Define the output first, then choose the approach that fits it. If you can't fill in that sentence, you don't have a machine learning problem yet. You have a wish. An LLM predicts the next token. That's the whole mechanism. It's a statistical model of how words follow other words, trained on a giant scrape of the internet. LLMs manipulate words. They don't manipulate reality. A word is not the reality. Common Crawl doesn't interact with reality. The model text is not reality. Your churn rate isn't in Common Crawl. Your inventory isn't in Common Crawl. It has never seen your business. A structured table known as a target column and a few thousand rows train a gradient boosted tree, XGBoost, or a deep learning model with a neural net on tabular data. These routinely built general purpose language models for security and reliability, and because they're fitting your distribution instead of the internet's. This will only produce the, the answer within your domain. Same churn, two paths. The top one is an LLM. Path one, prompt engineering, per call costs, unexplainable output. Path two, a CSV file of your data, one target column, 20 minutes, and a chart telling you exactly which signals drive the prediction. LLMs are a great interface. They're a poor substitute for a model that's actually seen your data. So before your next AI project, open the data, find the target column. If it's there, you already have the answer. You just need to train your model on it and fit to it. I'm putting a churn example end to end in the next video. You can subscribe if you want it. Cheers.